Our presentation for Sustainability Transportation Plan examines EV adoption into the transportation sector. EVs are becoming more common, but complete transition from internal combustion engines does not come without barriers. This plan examines environmental, social, and economic impacts of EV adoption by reviewing data surrounding charging infrastructure, range anxiety, technological advancements, and stress on the grid. We also give recommendations of how corporations and consumers can contribute to a sustainable transition to EVs. So we looked into what causes some of the key barriers to EV adoption. For example, charging structure is a big concern because there are charging stations that are few and far between, and they're also not conveniently and efficiently located. One cause of this barrier is the cost of updating infrastructure. Another barrier is range anxiety. So for consumers, range anxiety is a main reason why they will not purchase EVs. The range on more affordable vehicles has historically been low, about 70 to 80 miles. Ranges would need to increase for more affordable vehicles for people to really make the transition. Another factor is stress on the grid. With the amount of EVs on the road increasing, we must consider grid stability. The current grid infrastructure was built back in the 1950s and only had about a 50-year lifespan. For technological advancements, tech needs to keep up with the demand for EVs. People want long ranges, more charging stations, and with this comes updating the grid. Some environmental management issues include EV sustainability. Battery composition uses the mining of scarce metals, a process that is harmful to the environment. In addition, energy from the grid is mostly coal generated, so we would need to change this to renewable energies in order for EVs to really be truly sustainable. Positive impacts include a large-scale adoption of EVs, which could eliminate direct emissions from vehicles, also promote investments into renewable energy and grid technology, and reduce our overall use of fossil fuels. Negative impacts include emissions from fossil fuel combustion for electricity generation and any emissions created by the construction of new EV infrastructure. Due to the reduced tailpipe emissions of EVs only produce approximately 2/3 of the life cycle emissions of an ICE vehicle. In addition, the total life cycle emissions of EVs could be reduced to less than 1% of that of ICE vehicles if the energy used in EV production came from all renewable energy sources. A large-scale adoption of EVs would also reduce our reliance on fossil fuels, creating a decrease in fossil fuel production. Newman and Kenworthy's sustainability indicators that are most present in this plan relate to both energy and air quality and transportation. However, those that relate to the transportation contradict sustainability regarding transportation. This plan still emphasizes on vehicles and vehicle-dependent infrastructure, which a truly sustainable transportation system shouldn't emphasize according to Newman and Kenworthy. The truly sustainable aspects of our plan focus on alternatives in transportation energy and therefore satisfy sustainability indicators surrounding energy use, emissions, and air pollutants. There are several case studies that examine various barriers surrounding the mass adoption of EVs into the transportation sector. The studies that we concluded examine range anxiety, charging infrastructure, technological advancements, and stress on the grid. The main concern with range anxiety surrounding EVs is reliability. For there to be an incentive to decrease automobile dependence, transportation must be successful, reliable, and legible, and it must compete in speed with road traffic. One way to combat range anxiety is to increase the availability of chargers in public spaces. A study conducted by Bongs and Lusk discovered that more desirable parking spaces attracted more EV users. Figure 1 depicts placement of charger in parking lots. Chargers that are placed in the corner of the lot as seen in point 1 and along one edge as seen in point 2 result in less chargers available to drivers. This relates to charging infrastructure and how it can create barriers for EV drivers. Newman and Kenworthy state that if the infrastructure is built around transportation priorities, it can contribute to the end of automobile dependence. One way that cities can contribute to the end of automobile dependence is by prioritizing renewable energies into charging and grid infrastructure. A study by Nannenhauser and Q discovered that the amount of charging utilized by consumers significantly increased when the charging infrastructure was sourced by renewable energies. So technological advancements can actually help reduce stress on the grid due to the high influx of EVs. Smart load management centers act as a potential solution to grid stress and congestion due to the uncoordinated charging of EVs. This mechanism employs an algorithm that varies the amount of electricity available to the grid at different times to efficiently provide electricity for EVs. Vehicle-to-grid technology also allows an EV to store electricity and then return it to the grid. This also suggests smart charging, which decreases the amount of money spent on energy as another potential solution to stress on the grid. Smart cities already harbor sustainable goals, and increasing EV presence in smart cities can be a way to rejuvenate the automobile urban fabric, as discussed by Newman and Kentworthy. Much research has already begun to explore the grid integration of EVs in smart cities and how this can effectively become a business model for an essential energy service provided by EV owners. Government subsidy programs can be used to reduce the inequities in EV technology affordability. EVs have a better overall cost savings than ICEs because of fuel savings and lack of operations and maintenance costs. These bidirectional charging paybacks will incentivize greater levels of adoption. The potential for greenhouse gas emissions reductions is immense, since the transportation sector alone contributes roughly to 1/4 of the total global greenhouse gas emissions, which are projected to increase from 23% to 50% by 2030. The reduction of CO2 emissions and increasing the energy efficiency of vehicles are critical steps toward lessening global carbon footprints. The major benefits to public health, national security, and grid support will prove essential in the coming decades. Additionally, the main ways in which the EV industry can provide more equitable financial opportunities and shifting jobs to this emerging sector through the fossil fuel decoupling is immense and intrinsically interwoven with the previous economic sustainability perspective. This plan looks at the importance of increasing the use of EVs on a large scale, the barriers to doing so, and the environmental impacts related to such a plan. Increased VMTs of EVs on the road cannot be introduced without necessary development that improves charging infrastructure and availability of EV charging stations, stress on the electrical grid, and EV technological advancements. These barriers need to be overcome while also avoiding any negative environmental impacts that this infrastructure development could create. The key to overcoming the barriers preventing widespread EV adoption lies in incentivizing corporate investments into technological advancements in infrastructure development. Corporations can invest in technological improvements for range, fast charging compatibility, bidirectional charging, and updating grid capacity necessary to meet the demand of EV adoption. Consumers must seek out information regarding purchasing an EV to become unguarded about the barriers EVs may seem to possess. With an increase in education surrounding EV adoption, consumers are more likely to have faith in EVs and thus will become more willing to make the swap from gas-powered vehicles to electric ones. EVs are a more sustainable transportation option than ICE vehicles, given the need to drastically reduce greenhouse gas emissions in the next century. Widespread use of EVs will eliminate direct emissions from the use of automobiles and can drastically reduce the amount of fossil fuels required to meet our current transportation needs, despite our current infrastructure. While EVs are the most sustainable option for the future of transportation, the increased adoption of EVs cannot be possible without increased investments into EV and electrical grid technology. Without these investments, current EV battery technology is not competitive with ICE vehicles, both in price and vehicle range, and must be improved. Furthermore, a transition to the use of EVs on a large scale without investments into and improvements on electrical grids could create too much demand for electricity and overwhelm electrical grids. Although EVs are a more sustainable mode of transportation, the widespread use of EVs cannot be truly sustainable if electricity is produced using fossil fuels. Therefore, a sustainable transition to EV use also needs to be facilitated by major investments into renewable energy technology that replaces fossil fuels for electricity generation.